Welcome to the demonstration of Vehicular Communication Attacks Exploration Platform. The physical platform consists of customized track on which the cars run to demonstrate CACC implementation during benign and attack scenarios. There are three major components: car 1 or the preceding car, capable of performing attacks; car 2 or the victim car; and a roadside unit also capable of performing communication attacks. Application is hosted on car 1 and accessed through VNC Viewer. User double-clicks on the icon to open a GUI through which user will be able to control the preceding car and also perform attacks. User enters a desired velocity and has an option to select noise to the velocity channel, enters the acceleration, and selects desired CACC control model. User clicks on Start Car button to start the car on physical platform. During benign scenario, car 2 follows car 1 with a minimal gap in between them. At any point of time, user can update preceding vehicle parameters by changing the values and clicking on Update button. The cars continue to operate in CACC mode with updated parameter values. The car automatically stops at end of the track. At the end of each iteration, the application runs attack analysis on the gap trend to provide feedback to the user. The tool also provides a visual representation of velocity, acceleration, and the headway trend between the cars. The user clicks on Reset Car button to reset the car to a different position on the track for upcoming iterations. A user can play with different input parameters and see the behavior on proxy cars for different scenarios. For a jamming attack scenario, user follows the benign scenario prerequisite by entering preceding vehicle parameters and by starting the car. During this, user provides input to attack parameter values like packet count, interval, and duration and clicks on Start Attack. During this attack, we observe an increased gap between the cars, caused due to packet losses in communication. This leads to performance degradation in CACC implementation. The analysis tool provides feedback to improve jamming attacks by changing certain parameters. Corresponding plots are shown to the user for attack scenario. User provides input to preceding vehicle parameters and starts the car. During this, user performs hardware attack on victim car sensor by entering trigger frequency and starting the attack. The victim vehicle sensor perceives incorrect information which results in increased gap between the cars. The attack analysis tool provides respective feedback to the user and corresponding charts for sensor manipulation attack. The user enters preceding vehicle controls and clicks on Start Car button. During this, user has option to corrupt three communication data channels: velocity, acceleration, and position. User selects velocity data, which is less than the actual data, and corrupts the channel. As you can see, the distance between cars is increased due to the data injection attack. The analysis tool shows performance degradation as a feedback. Similarly, a higher value of velocity data is entered as false data. In this case, the cars collide with each other as the communicated data is more than the actual values. Different behavior can be seen by selecting other control modules from the GUI. The analysis tool provides respective feedback for the attack scenario, followed by feedback plots, which helps in better understanding of cybersecurity attacks. Only a few scenarios have been shown in this video for demonstration purpose. User can play with different attack parameters and control models and explore other scenarios.